Hi, this is Dr. John Bergdorf. In this video, I'd like to work an example of a motion problem, a problem that involves distance, rate, and time. Here's an example. Marcus and Deshawn both leave the Rice Lofts in downtown Houston at the same time, driving north towards Dallas. Marcos drives at a speed of 60 miles per hour, mph, but Deshawn drives at a rate of 70 miles per hour. After how many hours is Deshawn 30 miles ahead of Marcus? So here's a picture of the Rice Lofts, which are now a condominium, but were originally a very famous hotel in Houston. And the two guys are leaving here and heading towards Dallas. If you know anything about traffic on Interstate 45, the only way that they could be having these kinds of speeds is if they're driving in the middle of the night. Let's look at this kind of question in general. So when you have a motion problem that involves distance, rate, and time, the underlying formula is given by this. The distance, which we'll abbreviate with a d, traveled by an object moving at a rate, r, or speed, for time t, which needs to be given in a consistent unit with the distance and the rate, is given by this very famous formula, distance is equal to rate times time. Let's relate that to this specific example, which I've copied here. Marcus and Deshawn both leave the Rice Lofts in downtown Houston at the same time, driving north towards Dallas. Marcus drives at a speed of 60 miles per hour, but Deshawn drives at a rate of 70 miles per hour. After how many hours is Deshawn 30 miles ahead of Marcus? So I recommend that we handle a distance, rate, and time problem by drawing a little chart to keep us organized. Nearly every distance, rate, and time problem involves two trips of some sort. In this case, the trips relate to the two guys, Marcus and Deshawn. For each of them, they travel a certain distance, which is equal to the rate at which they travel times the time, and that's going to create a little chart like this. Often when you see a distance, rate, and time or motion problem, one of the factors, distance, rate, or time, is going to be just flat out given to you. In this case, you might realize that it's the rate or the speed. Marcus is driving at a speed of 60 miles per hour. Excuse me, let me get rid of this little strange little mark here. There, that's a bit better. While Deshawn is driving at a rate of 70 miles per hour. So that's just flat out given. There should be then something in the word problem that would give you a little bit of information about another one of the factors or columns. And in this case, I believe that thing is that the two guys leave Rice Lofts in downtown Houston at the same time. So the time over which the guys are traveling would be the same for both of them. We don't know what it is, but we can use the same variable, and we might as well just use time. Now, if you can fill out two columns of this chart, the third one can come directly from the formula. Since distance is equal to rate times time, the distance that Marcus travels would be 60 times t, and the distance that Deshawn travels would be 70 times t. That just organizes a lot of the given and unknown information, but it doesn't set up for you an equation. What you do next is you look carefully through the word problem and you ask yourself, is there any fact that I have not yet incorporated into my chart? That fact is the fact that will essentially become my equation. And you might notice that that not yet used information is right here, that we are looking for that time, that t, where Deshawn is 30 miles ahead of Marcus. This is saying that Deshawn has traveled a distance 30 miles greater than that of Marcus. So although there's more than one way to set this up, what I might say is that the distance that Deshaun has covered, which is 70t, is equal to the distance that Marcus has covered, but 30 miles farther. He has gone an extra 30 miles. So the distance Deshaun travels is 30 more than the distance than Deshaun has traveled. I think I said that right. The distance Deshaun has traveled is 30 miles more than the distance that Marcus has traveled. That finally gives us an equation, and that's what we're looking for. Now we just need to solve the question and make sure that we answer the word problem. So let's take a look at that. Here's the equation again, 70t equals 60t plus 30. I want to solve this for t. And to do that, I need to make sure that I have all my t terms on one side. I can make that happen if I subtract 60t from both sides. On the right side, the 60t minus 60t will give me a 0, and that's gone. And on the left side, I can combine like terms, and I would have 10t is equal to 30. And then that can be solved very simply by dividing both sides by 10, and that will get me to the final result that t is equal to 3. Looking back for a minute, t is an element of time. The question is, after how many hours is Deshaun 30 miles ahead of Marcus? The answer is, after 3 hours, Deshaun is 30 miles ahead of Marcus. And that's how you solve that problem. Now, when you solve a word problem, it's not a bad idea to kind of take a glance back at what you've seen to see if it is relevant or appropriate with the information that you have. And I'm going to try to illustrate that. So we know that Marcus and Deshaun have now driven 3 hours. We know that for sure. How far have they each traveled? Well, since we have this underlying relationship that distance equal rate times time, Marcus will have traveled 60 miles per hour for 3 hours, which would mean he has traveled 180 miles, while Sean has been driving at 70 miles per hour for 3 hours, and he has covered 210 miles. Is that indeed 30 miles more than what Marcus had driven? It sure is, so that seems to make sense. And if we happen to know another fact, we can also make sense out of this. It turns out that Dallas is approximately 240 miles north of Houston. So if we look at these distances, we'll notice that Deshaun is getting pretty close to Dallas. Marcus is traveling a little bit farther behind. What might have happened if we had made a mistake? Suppose we made a mistake and that at this point we had come up with the conclusion that, say, Deshaun had driven 600 miles. Well, that would be a clue to us that we probably have made a mistake because he would have blown way past Dallas. In fact, he'd be up like in Wichita, Kansas at this point. That wouldn't tell us what we did wrong, but it would give us a hint that we did something wrong, and we could go back and think through our work and see what we could come up with. So that's a nice example of a motion problem or a distance rate and time problem. I hope that was very helpful.